Alrighty, so in this tutorial, we're going to be talking about how we can make a weapon system. So to start, I've created a very new, simple project, and I've set up inputs and controls. I'll be sharing this with you guys, and I can show you how I do that in a second. But pretty much what this project is doing is when I click somewhere, it'll say I shot, origin, and where I shot. Okay, so I've set up all these scripts, and if you're curious and want to take a look at them, let me actually just make a folder so it's a little bit organized. Scripts. Move all of these into here. Okay, and then I can actually give this to you guys really easily, and there's going to be a link in the description of the video for this. If you go to right-click, and then export package, and you can export everything just like this. Now prefabs is empty, so we don't export that, and the scenes doesn't matter, you guys don't need this scene, so I will export all of this. Okay, and it's going to be called, it doesn't really matter, I'm just going to call it shooter demo. And I'm going to put it on my desktop so I can remember it for you guys later. Okay. So I might not be able to finish all this because I do have my other job coming in soon. But yeah, so let's get started. So we're going to make a weapon system that'll shoot from the camera position to wherever we need it to shoot to. Kind of like duck hunt type shooting. Pretty straightforward. So first of all, let's go to our scripts folder and let's go to the weapon base script that I made. We need 2 scripts for this to work. Well, 3 really. Player, weapon space, and projectile weapon. And an input manager if you want to be able to receive input, just like we did in the classes. So let's start by going to weapon base. And this is kind of like the main script that we're going to be editing today is our weapon base script. Now, I do have this open on the side as well, because there is quite a bit of code, and I do want to make sure that I get through all of it without wasting any additional time. Okay, so let's do it. Our weapon-based script is kind of like the gateway to all of our future classes, because there's a lot of great optimizations and qualities that we can do to this to improve this, and things we can talk about. In the next one, for example, we're going to be talking about rigid bodies. We're going to add a character, and when you shoot them, they will ragdoll. And it's pretty easy to do that. So, let's get started. Think about things that your weapons are going to have. Now, weapon base is something that every single weapon is going to have. It doesn't matter if it's a laser, cannon, pistol, bow, wand, sword. All weapons should have these traits. So let's add a few of them. We could say serialized field, protected, so that way our children are able to access this field, and then float, and then let's say time between attacks. This is going to be how long it takes for your weapon to attack. Let's make another one. Serialized field, protected float, and it's going to be our charge up time. And again, another one. And this one, we're going to put a slider on it, range between 0 and 1, and it's going to be a normalized float, which means that at 1 is 100% and 0 is 0%, and you can never exceed that range. We're going to say protected float min charge percent. And then finally, we want the ability to have some weapons be fully automatic. So again, another serialized field. Privates, bool, and then is fully auto. Okay, now we can organize this. Let's make a header, and let's call this weapon stats, weapon base stats, like that. Okay, great, that should be ready to go. Now, before we continue, there's kind of an important concept that we need to discuss. In object-oriented programming, we like to break down objects and compare things that they have in common and can do in common. So every object will have all of this stuff, right? And every object can attack, that's why they're weapons. But the way that they do things is different, and an important distinction is what is actually a weapon. Nothing is a weapon per se, but there's a more specific way to say it. We have a gun, we have a bow, we have so on and so forth. Another example is nothing is an animal. I could say a human is an animal, but a human is a human as well. You can't just say I have an animal. What animal? Right? So it's the same thing with our weapons. And when we say something like that, what we actually want to do is we want to say public abstract class. And this is going to open a door for us later, but it also closes a door. So really quickly, just to show you what making it abstract does, we're going to create an object, call it weapon. Okay, you can make it a box if you want. Let me just move it to 0, 0, 0. Okay, and now I'm going to try to attach the weapon base script, but I can't because it's abstract, which means there is no such thing as a weapon base. So we're going to come back to Unity in a moment, but I just wanted to show you that. Continuing, let's go back to our code. Okay. And in here, we are now able to start making some of our other variables and functions. Let's start by making our functions. First, we need our interface functions, and these are functions that'll be accessible in our other files. So we need our public void, and then start shooting. And then we need our public void stop shooting. And these are our interface functions because our player is going to ask the weapon to start and to stop shooting. Okay? We need some more functions. We need to make a bunch of timers, and we need to make some control functions. Next, the reason we made it abstract is because we want to say every weapon can attack, but they don't all attack the same way. So we're going to make a protected abstract, meaning we don't know the implementation of the function, void attack. Okay? Now, because this function is abstract, you're not going to do squiggle brackets. We're not going to say that it does something, because it doesn't. We're going to say it does nothing, and the child will tell us what it does. And that was a weird pronunciation on my part. But yeah, the child will say what it does. What I mean by that, let's go to the projectile weapon script now. Change it from mono behavior to weapon base, so it's now a child of weapon base. You'll get this error, and you can resolve it by pressing implement missing members. And there we go. So now we're overriding the attack function. Okay, and you can add a print line in here, and you can say, my weapon attacked. This is automatically going to sync up with the type of weapon you have, and this is a polymorphic property. It's something that you should have been learning in class. But effectively, what this allows us to do is we can now have a weapon base script that we can access. We can have an array of weapon bases, and then all you need to do is ask your weapon base to attack, and automatically it'll choose the correct attack for whatever weapon it's supposed to be. For example, if you had a bunch of animals and you asked all of them to talk, a human would say hello, a dog would bark, and a sheep would go baa. That's it. So, continuing. What we need to do now is we also need to have a bunch of timers. So we're going to have a timer for our cooldown, and to make a timer, we're going to say private, because only we should be able to access this, enumerator, and let's call this cooldown timer. And then in here, just to remove the error, we're going to say yield return null. Wait until the next frame. It's temporary. We're going to change that in a minute. And we need another one, private enumerator, and it's going to be called handle refire timer, or refire timer. Okay, and then again, yield return null. And the idea behind this is, yes, you could have a timer that updates regularly and update with a float, and you're always counting or whatever, but the disadvantage to that is it's always updating. So even when the weapon's on the floor, even when it's in your pocket, it's always updating. We don't exactly want that. The enumerators allow us to only make it do work when it needs to do work, is the major advantage here. And another advantage to this is it will still do work even if it's inside of like your inventory or on the floor. So this is always going to be true, and it's always going to be correct. Let's start by kind of just filling everything out and going in a normal order. So let's start by doing start shooting. When we start shooting, we need to call the refire timer function. So we're going to say refire timer, but you'll see that this is not a great idea. It's not going to let us do this, or it will, but it's not going to work the way it should. We need to say start coroutine, because it's technically, well, it is a coroutine. Now, we want to be able to determine if we are currently shooting. So we should store the output from this to remember if we are currently shooting. So I'm going to create a variable, a private coroutine, and I'm going to call it is currently firing, or current fire timer. Current fire timer, and it's a property, so it's underscore. There we go. Okay, current fire timer. And then what we're going to do in stop shooting is we're going to say stop coroutine, the current fire timer. So now we're able to cancel our coroutine. Okay? So our stop and our start are as easy as that. We're controlling our start timer, we're binding it to a new timer function, and then we are stopping our coroutine, and then that's it. All we have to do is ask the code to actually do these, and it should work. Next, let's take a look at our handle refire timer. What we want to do, first of all, is finish our cooldown timer, because we don't want to be able to shoot if we are on cooldown. So let's go to the top now, and let's add a boolean. Private bool is on cooldown. Just like that. Put an underscore because it is a property that's private. Great, and let's put it to use. So in our cooldown timer, we're going to say before yield return null is on cooldown is true, and after is on cooldown is false. And then instead of yield return null, meaning wait until next frame, we're going to say yield return new, wait for seconds, and we want to wait some amount of time. So we can create a variable at the top, which we have done already, time between attacks, and we just use it in here. Yes, but this can be improved. So our new keyword. When you're coding, you want to avoid the new keyword as much as possible. New is allocating memory to the heap. So what that means is you're increasing RAM usage. Okay, I will admit it is minute, but you should be thinking about this, and if you want to make professional games, you should always consider this. So let's go to the top and let's optimize. We're going to create a variable. It's going to be a private, and then wait for seconds, and let's call it my wait for seconds. Well, let's just call it cooldown wait, like that. Doesn't really matter. Again, an underscore because it's private. And then we need to bind it. And unfortunately, because this is not a constant variable, it is serialized, we need to bind it like this. We're going to make our start or awake function. It doesn't really matter. And then we're going to say our cooldown wait is equal to a new wait for seconds, or you could just do circles. And then you say time between attacks, like that. Cool. And you don't have to say wait for seconds, but you can. It doesn't matter. And now instead of this, we can say our cooldown wait. There we go. What is the warning here? Oh, it's telling me I should initialize it. Well, it's false. I don't know why it's telling me I need to initialize it from constructor. Oh well, don't worry about it. It is false by default. Oh, it's never used. Of course, my bad. Continuing. So, what we need to do now is we need to continue down here. So in our refire timer, we need to wait until our isCooldown is done. So we're going to say yield return, new, wait until, and then is on cooldown. But we can't just say it like that. We need to say our function is on cooldown, which is kind of strange. So we're going to wait until we are no longer on cooldown. And hopefully you've noticed here that there's a way to optimize this. And if you have, then you should have already gotten started on this. New, again. So at the top here, private wait until, and then it's going to be cooldown wait, cooldown enforce. I don't know. Doesn't really matter. And then equals new, wait until, our delegate, which is going to just return our is on cooldown. And then we chuck it in here. So you'll return new wait until, and then we'll just say over here, cooldown enforce. And there you go, it's optimized. Okay, so we're forcing it now to abide by our cooldown rules, but we should really be verifying that this is happening. So prints, waiting for cooldown, prints, post cooldown. Okay. Now, what we should do is handle our charging up ability timer, because a lot of the times in games you want the ability to charge a weapon. Sometimes it's only a few weapons that'll have this, but having that ability in general is kind of the objective of this. So we're going to say while and then we need to make a variable here. We want to be able to calculate the charge time as a percentage. Now, if you've ever calculated your grades before, you'd know that the current divided by the max is your percentage grade. So that is what we want to do. We want to calculate the current charge time divided by the max charge time, which is a variable we have, oh god, up here, our charge time, to solve the to solve the percentage, our charge percentage. So we're going to create a private float, current charge time. Okay, current and an underscore. And then I'm going to go back down. I'm going to say while the current charge time is smaller than the charge up time, then I'm going to say that the current charge time plus equals our time dot delta time. And then yield return null, wait until the next frame. Finally, I'm going to say over here, try attack. And this is ready to go. Now, our try attack function, and why we didn't just say attack immediately, is because normally when you're making a more professional game, you want your weapons to be able to customize their options for attacking. So this is kind of going to be like a gateway function that's going to have the ability to restrict us from doing a silly. So we're actually going to make two functions to go with this. We need to make first our private void try attack, which is going to prevent us from doing a silly. And then second, we're going to need a protected virtual void can attack. And it's virtual, so that way our children are able to modify what the rules for being able to attack are. Perhaps you want a weapon that can only attack if the enemy is in a certain distance, or if you are looking at said specific enemy, then you can attack. Well, you now have that ability, just by adding the word virtual here and correctly abstracting your functions. So, what we're going to do is really straightforward. First of all, we need to take our percentage, our try and attack percentage. So we're going to say float percent, and we're going to pass it down through all of these. And I'm going to move attack down as well, so that way it's with the rest of our attacking stuff. So just moved it down to here. I'm going to say float percent. Okay, let's fix this error. If we manage to get over here, then our try attack is 1. It must be valid. Okay? Yeah. Great, that is looking so far so good. We have an error now in projectile weapon, where we have this bit here. That's because we modified the definition, so we need to say float percent. Fantastic. Let's modify this as well, and let's just print our percent charge so we can see what's happening. Great. So now in our try attack function, what we want to do is we want to, well, we have our percent already. What we want to do is first reset the charge time, so that way, regardless of if we shot successfully or not, the charge time will go back down to 0. Current charge time is equal to 0. Reset the charge time. Then, if we cannot attack, let's say if we cannot attack, then cancel the function. And this way we can remove our brackets. So we don't need to add squiggle brackets because it's only going to do one thing, and it's going to cancel the function. And this is considered more professional sometimes, but you could also write it this way and then just put the rest of the code inside those brackets. I'm going to write it like this because this is considered more professional most of the time. Now, in our can attack here, we need our percent. So we'll pass it down. And I made an oopsie. This should not be void. It should be bool. Okay, and then in here, in can attack, if we can attack depends on two components. First of all, we'll return. And then is on cooldown, right? So if we are on cooldown, then we should not be able to attack. And if we are not on cooldown, and if we are our charge is greater than the min charge. So let's say if the current charged or the percent is greater than the min charge percent, and let's say greater than or equal to our min charge percent. And then that will actually permit us to shoot. Great. Now we want to flip this, because if we're saying it's the opposite, or, oh no, this is fine. If our percent is greater than our min charge to attack, and if we are not on cooldown, so if we have a 50% charge and we only need 40 to be able to shoot, then that should work. Great. Okay, so in our try attack function, if we cannot attack, then cancel. And finally, otherwise we can attack, then let's say attack, and let's pass through our percent. And now we want to be able to refire. So we're going to start, we want to be able to refire. So if, and then is fully automatic, there it is. If is fully auto, then we want to set the current fire timer equal to our start coroutine, and then it's our refire timer again. So this will automatically refire. And because it's only doing one thing, you can condense it like this. So again, we don't see any brackets, just easy to read. And let's add one last little bit, and it doesn't really matter where you put this. Actually, no, it does. It should go above this, my bad. We need to say start coroutine, and we're going to start our cooldown timer. There we go. Great. So when we try to attack, we're going to reset the charge time. Then, if we can attack, then we'll continue. Else, if we cannot attack, cancel. If we can attack, then attack on whatever weapon we're trying to do and pass down its percentage of its charge. Then give it a coroutine to execute, so it's going to handle its cooldown. And then if it's fully automatic, it'll wait until it can try to shoot again. Now let's head back up to stop shooting and start shooting. Start shooting is actually already good because it's going to start this infinite loop that we've created from our attack function. And stop shooting needs to be fixed because if you half charge a weapon, we need to be able to factor that as well. So in here, or let's, yeah, it doesn't matter. It doesn't matter where. So what we want to do first is we want to calculate our percentage. So float percent is equal to the current charge time divided by the charge time. Okay, so we have our percentage, and then all we want to do is we want to say if the P is not equal to 0, then try attack with our percent. And again, it's only doing one thing, so we don't need brackets. And there we go. Because we don't want to accidentally, if you have a weapon that has no charge, I should clarify, if you have a weapon that has no charge, then you don't want it to be able to shoot if the charge up time is 0. So if the percentage is 0, do not shoot. If it is not 0, then you can try and attack. Okay? Cool. All we need to do now is plug it in and actually implement our weapon logic. So let's go back to our game. And let's go to player. When our player shoots, what we're going to do is we're going to say, well, first we need a weapon reference. So I'm going to create a variable up here. It's going to be a private weapon base, and it's going to be called my weapon. And now here's what's cool about this. Serialized field. This is polymorphic. Polymorphism means of many shapes, and because a projectile weapon is a weapon base, that means that this weapon base is not necessarily a animal or a weapon. It could be anything, a bow, wand, staff, whatever you want, it's going to work, and that's what's awesome about this system. And again, there's a lot of room for improvement, not necessarily in like the actual logic, but more so in what we're doing up here. And I hope to be able to show you guys that, although it might be second semester. Continuing. What we're going to do is we're going to ask our weapon to shoot. And we also want to ask our weapon to stop shooting. But we need to be able to actually control this. So we're going to make a toggle for it. Private bool weapon shoot toggle, which starts false by default. And when the shoot function is called, we're going to flip it like this. So the weapon shoot toggle equals not weapon shoot toggle. If weapon shoot toggle is false, the opposite of false is true, so set it to true. If it is true, the opposite of true is false, set it to false. So this is a flip. We're flipping it from true to false. Then we want to say if our weapon is trying to shoot, then start shooting. Otherwise, stop shooting. And again, it's only doing one thing, so we can organize it like this. And that makes it just really concise and clear what exactly we're trying to do. It's pretty much human readable. There are some things that could probably be worded a little bit better, but that's fantastic. Okay. There is one more thing that I intentionally left out. In our controls, we want to change from shoot here to button to pass through with initial state check on. So now we're able to read both when we pressed and when we released. Press save asset, and then this should be ready to go. On your weapon, add the projectile weapon component to it. Okay, and give it a time between attacks. So time between attacks is going to be 0.2 seconds between attacks. The maximum charge is 1 second, and the minimum charge is going to be 0. So I don't need to charge, but I can. Is fully auto is going to be true, and we're going to leave it like this. Next, on the camera, because this game we're going to be shooting from our camera, I have my player script, and I'm just going to drag and drop in my weapon. And let's give her a try. So I'm going to open console, and when I click, it says waiting for cooldown, and it says I shot. It looks like our cooldown might not be escaping. Okay. That's not good. 1 moment. I made a serious mistake. I forgot to say not is on cooldown, even though I had it right the first time I wrote it. Oops. Let's go back. Just to quickly show you guys once more what I did. I said our cooldown enforce should be while we are not on cooldown. Wait until we are no longer on cooldown. Because that was backwards. My bad. We don't want to shoot when we are on cooldown. Okay, and I might need to restart quickly. And now we have an input manager issue. Okay, sometimes Unity makes me sad. We're going to change this quickly, and we're just going to pre-cache a value, so that way it's a little bit better, I guess. Private camera, cam, plug it in over here. Private static, because it's a static class, and then an init. Our camera is going to be bound to the camera main. So we only do it once. We're going to assume that it exists, because if you have no camera, that makes no sense. And there is a downside to this. When you swap scenes, you're going to have to rebind it. But it's the lazy solution, and it's going to fix it. But I don't know why that didn't happen earlier. Just Unity's camera system is a bit weird. Here we go. So you can see it's auto-firing now. And it's firing with 1, and if I let go early, it is going forever. That's no good. Post cooldown, it is still actively attacking. Hold on. Okay, I see the mistake. When we stop firing over here, if we still have a charge percent, then we try and attack. However, if we are fully auto, then we kind of break it. So let's say if we are fully auto and the current fire timer is not null, and I believe that this will correct it. Let me just try this quickly. Okay, so that didn't fix it. We need to add a boolean in somewhere so that way this is correct. Maybe what we'll do is we'll say bool is refire and give a default value of true, which is kind of lazy, to be honest. And we'll just say over here if is refire, and then over here. Or we don't need to do that at all, right? We can say over here, if the percent is 1. Okay, and then it's going to be like, oh, you can't just say 1 because float error and whatnot, greater than or equal to 1. That's perfect. That's going to do it automatically for us. Yeah, that's it. Okay, so now when I click and I let go, you can see that I can shoot. It'll charge for a full second to do a full attack, right? And let me turn off collapse so it's easy to see this. If I charge for a full second, it'll do a full attack and it'll automatically refire. And if I let go early, then you'll see that it does a partial attack. Now, in the next bit, I'm going to show you guys how to actually implement this as a weapon. But unfortunately, I do have to go to my other job. So I'll see you guys in 4 hours! Okay, at this point, we're back, and I am exhausted from working. It is 10 o'clock now, it's been a while. And I finished the projectile script because, and this is going to be kind of weird, I was thinking to myself, this is actually kind of a neat game in general. We could pivot this and make it as an excellent way to learn Unity for the first time just the concept of the game, because everything is really straightforward and simple. Like, I did all of this in half an hour. I could teach this to 12-year-olds over 2 hours. They'd all get the content, and they'd have a fantastic, professionally prepared game. Hopefully you feel the same way, in the sense that you feel like you are learning professional grade content here, as this is what you would see in the industry. Let's move forward. For our projectile weapon script, ensure that your projectile weapon is a child of your weapon base. This will force you to inherit this function. In this function, we can control when we actually attack. Then we're going to store the ray from our input manager get camera ray. And this is a function that I made that will just return camera, screen point to ray, and the mouse position. And then in the permanent controls here, we're reading the mouse position every frame. Going back to our projectile weapon, we are storing the value of array, which means that we're storing both where it is, where it starts, and where it ends. Or rather, the direction, not really where it ends. It doesn't have an ending. Next, we get a rigid body. We create a rigid body by instantiating a prefab, which I named F, which we should totally change. Let's call this my bullet, just like this. And then the origin is where we're going to spawn. So the beginning of the ray in the center of the camera is where we're going to spawn. And you might want to change this. So keep that in mind. Where we're going to spawn is the camera's origin, and then it's going to be the rotation of just itself, which is nothing for now. Then we're going to say RB add force, and we're going to add force in the direction of our ray, which is where our mouse is looking through our camera, multiplied by force, and then our impulse. Now we're actually going to change this around a little bit. We're going to say that percent multiplied by force, okay, multiplied by our direction, and then we need to lock it. So mathf dot the max between the percentage, the force, the percent, and 0.1f, like this. So that way the minimum force that it's going to do is 10% of this force. So 5 instead of 50. It says that it's actually 10 right now, which is great. And let's do one more thing. Let's make it so that we were able to spawn different bullets based on how much we've charged our shot. So to do that, it's really quite simple. I'm going to do it the lazy way. I'm going to just duplicate this and call it my bullet 2. And then over here, we're going to make an inline if statement. I'm going to say if the percent is greater than 0.5 charge, half charge, then do my bullet 2. Else do my bullet. And just like that, we've created an interesting weapon that we can now add into our game. And there's nothing more that I added, I don't think. Really quick, we can take a look at the player, so you can make sure you're not missing anything. You can take a look at the input manager, make sure you're not missing anything, and take a look at weapon base, make sure you're not missing anything. And that's literally it. We've created the foundation for our game. And then also the controls. I might have forgotten this. In the control settings, make sure that the in-game shoots action is changed to pass through with initial state check on. So we're reading for both when we release and press the button. Now UI mode I added to show my employer, just kind of how this game would continue. And it's going to get kind of wild next week, so I would watch the video even if you go to the tutorials, because there's a lot that's going to happen. Okay, and we're going to shoot. And it said I have accidentally disabled something on this pressed. I see. Hold on, I might have accidentally messed something up when I was showing my employer. 1 second. That seems fine. Okay, let's try this again. I didn't change anything that you guys would have. And it says, oh, we forgot to set a variable. Classic. So we have our rigid bodies here and our force. Let's put the force back up to 50. And then we need to spawn in our bullets. So I'm going to go to the prefabs folder and I'm going to delete this because I made this without you guys. Right click and create a 3D object. Let's do sphere. This is going to be bullet 1, and I'm going to decrease the size. Press on this first, so that way it's constrained, 0.2, and it'll affect them all. Give it a position of 0, 0, 0, so it prefabs correctly, and then give it a rigid body. attach this into your prefabs. And then we're going to create another one, but the size is going to be bigger, size of 0.5. And then I'm going to prefab and unpack. And then I'm going to rename it and re-prefab it. So now you have two of them. And I'm also going to change the color of the second one. So I'm going to right-click here, create a material or bolt2, and I'm just going to make it red. And if you want to learn more about materials, I have other videos on this. But we can just drag and drop it on and apply it to the prefab over here. And now every time you spawn a red bullet, bolt2, it'll be red. So here you go, every time you spawn one in, they're red. Cool. Go to weapon and attach your things, bullet 1 and bullet 2, and it's time to test it. Now I shoot, and you see that if I charge up a shot, it goes much further, and if I charge it up enough, then it's red. And you see that I can charge it partially, we get a fast white ball, charge it up a little bit more, get a fast red ball, and it's fully automatic. Now the projectiles aren't being destroyed, so I'm going to add one more thing, and it also goes exactly to where my mouse is going, so you can already see why, like, such a simple project, this could totally be a game that you'd like the first game you make, right? Especially after you see next week's stuff. So let's go back now to our projectile script, and all we want to do in here is just destroy ourselves. So we're going to destroy our RB game objects after, and then 5 seconds. And that's it. Project's done. I'll see you guys next week.